他的那个我是写的事情。一开始看我就会先然后就看久了这个，就长大了过会很多遇到东西，比较多的比较强的，挖到线到第二个。
Okay, let's start our lecture. Okay. Now, just now we stopped at this pricing review procedure. All right. Next, we do high risk projects. Okay. So, how we know that project is high risk or not? We base on their history. Their history. History. So, for example, construction company, those developers out there. For example, Sunway Construction, IOI. What else? Seremban One Matrix, right? What else? Those well-established developer, they actually have a loss of IP, a loss of intellectual properties, loss of standards. So they know what is happening in the industry. They know the tools and so on. So they have a lower risk compared to those new companies out there, right? And they have a better tools out there. But for R&D, for new projects, then they have a higher risk. They have a high risk because you don't have data, especially when you develop new products. So this is the accuracy between the WBS from level 1 to level 5. So the accuracy, it depends on low risk and high risk. So if you look at the table here, if you WBS level 1 until level 5, the description here is on the program, project, task, subtask, and work package here. So the accuracy, if the project is about plus minus 35%, they consider low risk for level 1. But if the accuracy is more than 75% at level 1, they consider high risk projects. For level 5, for example, level 5, WBS level 5, if the accuracy is plus 2%, then they consider low risk. But those that are more than 5 and 10% accuracy, they consider high risk already when they come to level 5 WBS. So means the lower level you go, you need higher accuracy compared to decision makers at on the top level. Okay. So one techniques approach they use to estimate high risk project, they call it rolling wave or moving windows approach. Okay, what I mean by rolling wave and moving window approach? So this is, for example, this is the table for a picture for high risk R&D projects. So this is the first month until 12 months. And you have a loss of level, loss of level. So for example, case scenario A. Case scenario A, you have a level 5 and then continue with level 2. Okay. So part A, for part A, R&D efforts is accomplished for the first 6 months. So you do level 5. Level 5, they will work from first month until 6 months. And they can be estimated to level 5. Okay. But after works, month number 6 here, it based on the first 6 months and estimate at level 2 for occurring a high risk here. So the work done in level 5 is from first month until 6 months. Then it passed to level 2 already. Okay, so the first scenario is for R&D scenario. So the level 5 work for 6 months and then they pass to level 2. Okay. For B, there's a shift of window here. You see, for the 12 months project, they shift a little bit on first month and second month. They start at March, then they squeeze in for level 2. Okay. So in order to maintain a 6-month moving window at level 5, so what they do, they estimate month 7 must be improved from level 2 to a level 5 estimates. Okay, so here they shift the window a little bit compared to the first case. They shift a little bit. Okay, so the duration they need still 6 months, right? Still 6 months, but they shift and then they squeeze in the decision making for level 2. Okay, so this is called shifting window, moving window. So if you shift further the window over here, it will stress out the level 2 decision. It will eat the time decision for the level 2. Okay, it just squeeze the time for the projects. Okay. No, it just give you a scenario. What is the moving rolling wave approach? Okay, so it not necessarily 6 months. It's just that for a normal scenario, level 5 they need 6 months, and then they pass it to level 2 for approval and all this. So this is a normal case for R&D. But what I mean by rolling wave is that when you shift the level 5 works to shorter times, it will squeeze in the level 2 decision windows. Okay. No, level 2 cannot move. Not cannot move lah, but you cannot cut short level 5 work. Means if level 5, let's say level 5 is lower, those that doing real groundwork, they tell you they need 6 months. So the more drag you have, level 2 need to do more work within for example, the last scenario. Level 2 need to do work within 3 months compared to the first scenario. Okay. So when you do this moving window approach, you need to look at the length of the moving window. And the second one, which work best for the upper level management to understand. Means if your upper level 1, 2, 3, they able to make decision quick one, then you have able to move your window more flexibility. Okay. So if your top level WBS level 1, 2, 3 cannot make decision one, always need like 6 months and above to make decision, then this moving window is going to destroy your projects. Let's say your project is 12 months, but when there's a delay in some of the component, then it will drag the projects. And sometimes if you delay your projects, the penalty cost is there. Okay, so there are methodologies to develop the assessing risk also, a very lengthy process. Okay, so this one also you go and read at your free times, right? Go and digest what is happening from the top to bottom. Okay, so this is another for base cost and risk contingency. So there are 2 tables here. So go and read, and when you have free times, decision elements for risk contingency, element for base cost and risk contingency. So there are two table there. Okay, so these are the zoom out for the diagram. Okay. So for your FYP reports, make sure you show something like this in your report because you are managing a project. Okay. So they should have a flow way in doing that. Okay. Your FYP or any projects. Okay. Okay. So project risk, this one you read. What is important is why there's a risk happen in the projects. Either you don't have a proper definition of your customer requirement, you don't know what your customer want, you have a lack of resources, you have a lack of management support, you're poor in doing estimating, means sometimes you have lack of data, especially you're handling new projects, R&D projects. You don't have enough data. Or you have inexperienced product manager. Okay, you don't know how to handle people. Okay, so these are the risks that you need to consider when you handle new projects. Okay. So what is the definition of risk? What is the definition of risk? It refers to dangerous activities or factor. If they happen, will increase the probability that the projects will fail. This is a definition. It's a definition of risk. What is risk? Okay. Okay. So what are the tools that help you to reduce the risk? First, you have a system, expected measures, trend analysis, and dependent reviews and audits. So these are the tools that you can use for project management. Okay, to reduce risk. So you have 4 tools that for there to help you. Decision support system, expected time value measure, projection, and audits. Okay, audits. So there are steps for risk management process. You identify, you quantify, you prioritize, give priority, you develop strategies, and then you go for review. This is a general 6 step. 1, 2, 3, 4, 5. Okay, one more. Then take action. 6 steps. Okay. So remember these 6 steps for risk management process. Identify, quantify, give priority, develop a strategy, get approval from top management, and then go ahead and proceed the action. Okay, 6 steps. Next, we talk about life cycle costing. Life cycle costing. What mean by life cycle cost is a total cost. It's a total cost of the products over its full lifetime. Okay. So there are a few breakdowns in the life cycle cost. First one is R&D cost. So the explanation you read. Okay. First one is R&D cost. Second one is production cost. Okay. Total breakdowns for the life cycle cost for the product for or services. First is R&D cost. Second, production cost. Third one, construction costs. Fourth, operation and maintenance costs. So there are lots of things you can read. So important, I highlight the points. R&D costs, production costs, construction costs, operation and maintenance costs. Okay. And then is a phase out cost or disposal cost or product retirement cost. Like for example, you manufacture Model X electric car. So you need to consider the disposal cost for the car. Like how do you handle the batteries, for example? Right. So there are a few courses there. Courses. Analysis. Successful life cycle costing. What will it give you? You have 4 benefit there. It will give you impact of visibility for the resources. Okay, so if you have a life cycle costing that the 6 costs now, 6 or 7 costs now, it will give you your team know what actually the projects or the products, how you handle the projects, right? Because you might be the next one who in charge of a certain component of the project. Let's say the Model X automotive industry, the Model X with the EV vehicles, and you might be in charge of the disposal phase. So from the project itself, you actually know that the company have some budget for that for the next 5 years or 10 years, right? Product life cycle cost management, R&D decision making, support downstream strategy budgeting, and so on. Okay. So limitation to LCC or life cycle costing. Limitation is that we have an assumption that the products has a finite life cycle. We assume that a certain products, especially things that you can touch, you can sell, customer can touch one, they have a certain amount of life cycle. For example, once you sell it, let's say sports shoes, maybe it can last for 2 years for an elite or for professional players, for example. Okay. High cost to perform. High cost to perform if the volume is very low, right? If the volume is very low, or high sensitivity of changing requirement. For example, if you are the one who handle the COVID test kit, nowadays you don't need test kit anymore. So you need to have this, when you do the life cycle costing, you need to consider also, right? Okay, the rest you read. Okay, so they are all these method, they are all these method, estimate method. We have informal and formal methods. Okay, informal and formal methods. Okay. So for this module, we will focus on formal estimating method. Okay. Later you'll learn the method for that. So there's a chart table also. So this one also you read again. If not mistaken, your test 1 question will ask you advantages and disadvantages kind of question. Okay, earlier I didn't mention this one, right? So since I saw this one, I think I'm asking you question about advantages and disadvantages. This one question asks you about advantages and disadvantages. So you go and see the material inside there. Any question asks you advantages, disadvantages, focus on that. Okay. Okay, this one you read. Common errors will be all these okay, common errors in the life cycle cost analysis because of the data, misinterpret, misuse, failure to check, and all this. Okay. Okay. Now we look at the time value of money and discounted cash flow. This also is a very important component for your test and also final exam. Why? Because there is a formula coming in. Okay, things that you can calculate, sure will come out in the assessment. first equation for today. FV equal to PV bracket 1 plus K power N. What is FV? Future value of your investment. PV is present value. 1 plus K, K is the investment rate or cost of capital, investment interest rate capital, N is number of years. Okay. Of course, this formula is very old. With more high-tech big data analysis, there are some formula adjusting for this one. So maybe the more accurate K value from the database that you have. Okay, so they can estimate whether good or not the investment. Okay, FV equal to PV bracket 1 plus KN. So if test 2 or assignment, your final exam come out, please write this equation and then explain what is FV, PV, what is K, what is N. Don't just write this equation and then without explanation. Okay, write this and then explain what is FV, PV, K, and N. You write this one, you get, with the explanation, you get 2 to 3 marks. So this is the only equation, if not mistaken, for chapter 6. Okay, big issue for engineering student because you can handle partial differential and all this. So this is very easy. Okay, so example, so with the investment of $1,000 today, so if you see the question, say the word today or current value, then that is a PV, is a present value. PV is 1,000, invested at 10%. 10% is an investment interest rate. Okay, investment interest rate in the question, you see percentage 10% for 1 year. 1 year is N. Will give us a future value of how many? If you press calculator, what is the future value? If you substitute 1,000 here, K is 10%, N is 1. So how many? What does your calculator tell you? 1,000. 1,001, Okay, 1,001, Okay. So if an investment yield, 1,000 a year from now, then how much it worth today if the cost of money is 10%? What is the answer? Of course, it will be less than 1,000, but what is the number? So you just, okay, investment yield, what, 10,000 a year. A year is your N from now. So N is 1. So future, this is a future in a year from now, so it's a future value. So 1,000 is here. Okay, so if the cost of money is 10%, so 10% is your investment rate or cost of capital here, 10%. So you put in 10%, you move around the equation, 900 something. Okay, so it's 900 something. So there's a word, we call it discount future values. All right. So this question here is actually asks you about discount future values. Refer as discounted cash flow. Okay, this kind of question will give you, the answer is actually if you see the question asks you calculate the discounted cash flow, it actually asks you to rearrange the equation to find the missing parameter inside there. Okay, So this one, you just rearrange or you just substitute, you'll get 909. Okay, so this is a discounted value. Discounted value. Okay, so the expected answer, if this kind of question come out, is very easy to score. So what I expected is that you substitute the value and then you give me the answer. Okay. Unit is important, right? If normally in the question you'll see ringgit Malaysia, don't be dollar. Okay, so nothing complex here. So 1,000 a year from now is only worth 900 something today. Okay, it just means when you do this kind of calculation, so yeah, so 1,000 a year from now with 10% of interest rate, or can say as a, what's the term already? Inflation rate. Okay, so you only worth 900 something today. Okay. Okay. So what does this equation will help you in your investment? So if the interest rate K is known to be 10%, then you should not invest more than 909 to get the 1,000 return in a year from now. Means you cannot go more than $909 if you know that the interest rate is 10%. Okay, why? Because the 1,000 1 year later it only costs the present value 900. So if you invest more than 909, means actually you lost money already. Lost money already. Okay. Okay, the rest is there. Okay. Now, however, if you purchase this investment for 875, for example, okay, just now you calculate 900 something. It's an equal value of 1,000 in the future with 10% interest rate. So if you invest with 875, means you reduce your capital a little bit to 875 now, your interest rate will be more than 10,000, more than 10% if you want to get the similar 1,000 in return 1 year later. Okay. So if you substitute the value there, you know that your K value will be more than 10%. Okay. Okay. Now another example to apply this formula. You have a choice between two investments. Okay. This kind of question will come up. So he asks you for your decision making, whether it's a good investment or which one you should go. Project A, project B. Explain why. Okay, so you have two choices. Investment A generate 100,000 2 years from now. Investment B generate 110,000 3 years from now. Okay, if the cost of capital is 15%, which investment is better? Meaning you make money. Okay, so you are given the value of K. You want to calculate the current value, the current investment that you should pay now to get the future value, right? So you have two value, two scenario. Investment A will give you one current value or present value, PV. Investment A give you one numbers. Investment B will give you one numbers also. Only the N is different. A is 2, B is 3. The K is fixed. K is 15%, 0.15, right? So if you do, present value for A will be 7,000 something, right? Yeah. B will be 72,000 something. Okay. So it implies that a return of 10,000 in 2 years is worth more than the firm that in return 3 years from now. Okay. I do the simple calculation for you. Huh? You invest A, you invest 75K. B, you invest 72K. A, you need only 2 years. How many you get? 1,000. This one, 3 years. You get 1,010K. How many profit you get? 75 to 1,000. 25K, right? Divide by 2. 12.5K per year. This one, how much? 110 minus 10. Huh? 38. Divided by 3, how many? 12.6. 12.6. But this one is a rough number lah. So it's round the numbers. You invest 75, you get 10,000 in 2 years. But you invest 72, you only get like more 10,000 more for you need to wait for 1 more year. Yeah. So if you drag this one to 1 more year, same, you drag this one to 2 years or 3 years, you actually get more. You get more. If you drag the same duration, you get more for case A. You can see, okay. Okay. It is about investment lah. Like there are 2 scenarios, which one is better? Okay. Okay. Next one is the net present value method. It's a little bit complicated, but the equation is still very simple. NPV, net present value method, for that help you to equal the discount cash flow against the initial investment. It looks complex, but not very lah. So NPV, net future value, net present value, equal to sum of future value divided by 1 plus KT minus the initial investment. II is the investment, initial investment. Okay. So it's a sum. It's a sum from the time that you calculate. So I give you one example how to apply this equation. So you have 2 equations. Okay. T is the time period where the cash flow ending period. So copy this equation. NPV equal to sum T equal 1 n bracket FV sub T. Sub T, this is a sub T divided by 1 plus K superscript T minus initial investment. So I give you one example. So this one I show you by using Excel, but you should able to do it when it comes to test. You should able to do it using calculator. But you draw the table also like if you want. This is just the same. This is a formula I use for Excel. So NPV, if you compare side by side, the equation actually the same. It's the same. Okay. Then I will do the formula. So CF here is your cash flow in N period. Okay. So future, this is a future value. So CN here is the future value. Okay. So I'll show you the example using Excel. Okay. So assuming your initial cash flow of the project is 10,000, invested for a project, subsequent cash flow, you have a cash flow coming in. For each year, for 5 years duration is 3,000. So your initial investment is 10,000. Then year 1, year 2, year 3, year 4, year 5, each year you get 3,000. Make sense? Okay. So if you have a property, you do renting one, you know this. Okay. The discount rate is assumed at 10%. Calculate the net present value. So your discount rate is 10%. So initial investment 10,000, and every year you have a cash flow 3,000 come into your account. So how do you calculate the net present value? So you use the equation just now. So okay, maybe I'll show you the. Okay, so if you put in the present value is you take the cash flow divided by 1 plus the rate. 1 plus the rate. Okay, this one you convert to 0.1. This one is 10%, it means 0.1, like the one that you calculate just now. Right? Bracket, and then this one is superscript. Superscript, how many years? This is the first year. So n is 1 here. Okay, so if you press a calculator, you will get 2,000 something for the present value for first year. Okay, so this you calculate for the first year. Then you know Excel have gone one function, right? You can drag to copy the formula. So here drag. Okay. So you continue to do the calculation. Okay. You drag the arrow, you calculate for the second year, third year, fourth year, 5 year. So you get all the value here. So when it comes to your test or final exam, what you need to do is that you draw something like this on the question paper or on your answer sheet. You just do this one, and then you use your calculator, press. You press, and then you build a table. Then you press it. Of course, you write the formula somewhere in your answer. Write your formula, then you press calculator. Okay. Okay. Once you calculate all the value there, then again use back the equation that you learned just now. All right. So you take the sum of all these values. This one plus this one plus this one plus this one plus this one. Then you minus the initial investment. Okay. You take all this value minus this one. You get the present value 1,000 something. Okay, so these are the format that are expected in your final exam or your test 2. Okay, so basically there's no very complex formula. You follow the SOP here, then you get the answer. What is the careless mistake is the formula. Maybe you memorize wrong and then you press the wrong button. Okay, so this is how you do it lah. This is how you do it. So nothing complex here. Nothing complex here. Once you understand the principle, then you're able to do. Okay, so this is another example. So table A, calculate NPV for the data provided in table B. Okay, so you should be able to understand this table by using the Excel form that I showed you just now. If you see that initial investment is so and so, and then year 1, your incoming cash flow, how many? Just now is the standard, not standard, but simulated value. With every year have the same value, but this one change a little bit, 1,000, 2,000, 2,000, 5,000, 2,000. But you use the same Excel format, and then you should be able to generate the present value just now. Only need to be careful is that the first year, second year, third year, the formula that you use, the T here. Yeah, the T here need to be careful. Don't confuse this one. Then if you read this table, once you generate the present value is 8,000 something, then you minus the investment. Your net present value is negative. Net value is negative. Means the bracket, if you see this symbol in the account reporting, it means negative. Okay. So this indicate that the cash flow discounted to the present will not recover the initial investment. If you have this kind of scenario, means your cash flow is like this, you will not get back the investment value. Because you have what? You have the what call the percentage, the percentage. Because you have a discount rate or inflation of 10%. So you're not able to recover your initial investment. Understand? Okay. So this is a very bad investment to consider. So this kind of question will ask you to justify whether this is a good investment or not investment. You build the table, then you look at the net present value. If it's negative, it is not a good investment. Or you get zero. Zero is just your comment. If you get zero net value, your comment is that this is you just mentioned that the initial investment is same as the net present value. There's no profit. There's no profit out of this investment, right? You will get back the capital, but you not getting any profit. So it depends on the. It's not when you get zero. It's not that good or bad. It's just that you get back your investment. It depends on the profile of investment or investor. So some investor they are called they are low risk investor, means they don't want to take risk one. So if you get zero, means sometimes it's good for the investor. They think that okay, I get back my capital, okay lah. But those that very high risk investor one, they want to get back investment one, then the projection is zero, then might not be a good case for them. Okay, it depends on the profile. Okay. Capital, but why you make it? You already consider inflation 10% in this case lah. I mean, if you get zero here, means that you get back your investment, but you still need to ask back the very fundamental question: why you make investment? You want to make money, not to get back your investment. Unless you're so rich, you just want to maintain the cash value in the future, then okay. But most investment you want to get money, right? Okay. Yeah, correct. Correct lah. So just recently I also exposed to the properties talk and all this. So yeah, so if you are in the if you're in the property, you know lah, you know. Yes. Okay. Okay. There's a decision go no go table. So if your NPV is greater or equal to zero, then accept the projects. Means the decision making as a project manager. So if your NPV is more than zero or zero, then accept the projects. Mean you do not lose money. But if the NPV is less than zero, then reject the projects. So this is the hypothesis, or this is the decision making. This is a statement that we are looking for if this kind of question come up. We ask you to justify whether to accept the project. So based on the value you calculate, You write any sentence of this one. Any sentence. Or you write these two also correct. If you don't know what to do, you just write these two, then you will get the answer. Okay. So yeah. Okay, I think we save this exercise for tomorrow. Okay, so at least today you have two equation. You have two equation to learn. Okay, with this we end this today lesson. See you tomorrow. Okay.